So if you were going to delete everything off a modern diesel, what would that look like? Although it might look like it, Optimus Prime did not just come in to take a dump on the shop floor. Welcome to Austin Fairford Garage. So if one were to do a complete delete on their modern diesel, this is pretty much what you're left with.
Caution. Caution.
Removal or bypassing of emissions equipment can lead to check engine lights, engine failure, failure to start, and of course, failure to pass emissions testing. Dependent upon your state and local emission regulations, this could lead to serious fines, confiscation, etc. So please, proceed at your own risk. Obviously, some of this, you need alternate means of routing certain gases, electrons, things of that nature. Probably the only thing that is basically just a complete delete that doesn't require any additional parts is the DEF tank. That pretty much just goes away. The everything else requires some sort of replacement part, delete kit, things of that nature. You're also going to need tuning. The computer does not like it when you remove these things and don't trick it into thinking it's either still there or just turning it off. So you'll need that as well. Some of this stuff can be a little tricky nowadays. A lot of this stuff isn't available here in the US, so you may have to find other means of acquiring said parts, but it is possible. And then obviously it is not going to be street legal. Once you do that, it is not going to pass any kind of emissions. It is not legal to drive on the street, things of that nature. So, but this is what it would look like. And this actually isn't everything. There are other parts. If you look at like full-blown race trucks, diesels, there is nothing but pipes and engine. That's it. They are extremely simple, which is one of the glorious things about the diesel concept. So, as far as benefits concerning the deletion of all these things, increased fuel economy. Some folks have seen 50% or more increase in fuel mileage. Lower EGTs, more power, just without increasing boost or anything like that, the motor just magically becomes more efficient. Alright folks, so first up we have our CCV, crankcase ventilation. So basically it's ventilating some of the gases back into the intake. There are contaminants. It does tend to load up the intake and the intake tract, everything in line with oil and contaminants and things like that. If you were to have to replace this, $150 MSRP or so. I'm sure you can find it less in different places. So next up is the EGR, exhaust gas recirculation. Now this is where it starts getting juicy, folks. This contraption here, you would think it would be relatively simple to just kind of recirculate some of the exhaust gas back into the intake. However, they've they've got quite the engineering feat going here. You've got coolant lines, you've got actuators, you've got vacuum lines, you all kinds of stuff. There's all kinds of things going on. Sensors. This structure here is actually cooling the exhaust gas, which isn't, I mean, that's a good thing. I mean, you don't necessarily want that extremely hot gas going back into your intake. However, there has to be a better way. This thing is about 50 pounds. Added coolant, all the aluminum, stainless, the electronics, the sensors, I mean, it is quite the piece. Some of these tend to fail from time to time. If you replacing the valve, this is all MSRP, $347. The vacuum valve, $177. The control valve, $430. The cooler itself, so all of this gets clogged up. Right, you get a diesel soot and things like that build up in here. It becomes less efficient, and then that core either needs to somehow be cleaned or replaced or whatever. The cooler piece inside here, $462. Now, none of this is labor. If you were to tackle this yourself, it is not a fun day. As I've said before, if you ever just wake up one morning and you just really want to do something that sucks, that's the ticket right there. Next up, this little peach is your DEF tank. So this is your fluid that is injected into the diesel particulate filter to help clean it. This is another modern marvel of engineering. You've got pumps, you've got sensors, you've got all of this stuff, and this is a 5-gallon tank, and I mean, you can see what all it takes into account. I mean, this is the plug going to it. I mean, how many wires do you need just to inject some fluid into something? I mean, it's insane. So if you were to have to do some of the maintenance on this, the pumps and things like that, you're looking at, so a pump is $510, and those go out. So one of the challenges with the DEF is that it crystallizes and things like that. Your lines may get crystallized if you're depending on temperatures and all of that kind of crazy stuff. So, and then just like everything else, over time things start to fail. So, like I said, pump $510. The reservoir kit, which is basically a lot of this stuff here, $485. The injector that we'll see later, $247. The tubing that runs from this to the injector, $225. And now for the belle of the ball. This is the diesel particulate filter along with the catalytic converter and things like that. So it's a chunk, probably 125 pounds, something like that. I think altogether, everything that we've looked at so far, you know, a full tank of fluid, your EGR, all this together, probably 250 pounds. And weight is not your friend when it comes to fuel economy. And I don't care what you're driving. So there's that. Now, the first portion of it, I believe, is catalytic converter stuff. You have your, all of this assembly. You have your diesel particulate filter stuff going on back here. This is your injector. This is where your fluid gets injected in here to help clean it out. You have temperature sensors. You've got, controls for your valves and all of that kind of stuff. There's half a dozen connections here, and it creates an immense amount of heat when it goes through its process. It's I mean, you can really tell it in the truck whenever it starts going through its regen process. You'll be down on power, you'll be down on fuel economy, on top of the loss of fuel economy just from having this stuff in the works. When it goes through its regen, it's really taxing the entire engine and everything. For the DPF assembly, you're looking at MSRP of over $5,000, not including labor, things like that. Now, obviously, with just like a lot of this stuff, I'm sure there's ways out there that you can get these things cheaper. There's probably folks out there recycling these, rebuilding these, recertifying them, things of that nature. I'm sure there's a Chinese version out there. I shudder to think how efficient it would be or what it would be made of, but I'm sure it's out there. So, however, that doesn't negate that you're looking at a sizable chunk of change when this goes out. So all in all, should you have to replace any of these components, it can be a chore, just like we talked about with each one. CCV the easiest. EGR system, that's a bad day. DEF tank, not too bad. You just have to remove, depending on your manufacturer. On this particular application, there was a skid plate, and then removing of the connections, and this is your filler neck here. So depending upon your application, it may vary in degree of suckness. This was kind of sucky, real sucky, not bad, not too bad, just a lot of connections, and it is heavy. But other than that, most folks should be able to do it themselves. Labor charges are getting a whole lot steeper, and none of this stuff is getting any cheaper. If someone were to delete all of this stuff for off-road applications, the key is the software. If you have the correct software or tune in your vehicle, some of this you don't even have to remove. The DPF you would need to remove just because of the massive flow restriction and whatever that thing causes. But the rest of this you can pretty much leave in place. It can essentially, the tuners can essentially turn it off. So it's not necessary to actually remove this stuff. So I guess my question is, once all of this is done, so you've mined, you've drilled, you've transported these components to be processed, then after the processing they have to be transported to manufacturing. Once they've been manufactured, they have to be transported to the factories to be assembled on the vehicles, all of that. Once all of that takes place, now also the components and elements that were used in this, the precious metals, all of that, were mined and drilled in a lot of cases from and imported from countries that don't even have emission regulations. So they're just pumping out whatever they want to in order to provide us the means to reduce emissions. So that's a conundrum in and of itself. It's almost like if you said, okay, well, I'm going to reduce the amount of fuel that I use. So I'm going to have everything delivered to my house. I'm going to do my part. I'm going to have everything delivered. Well, so you aren't burning the fuel to get everything to the house, but someone else is. So that's kind of what, like I said, we're having all of this stuff imported, a lot of this stuff imported from countries that don't have emission regulations in order for us to reduce our emissions. And the more of this stuff that we do, the more they have to produce. In essence, producing more emissions because they don't care. When this stuff comes from some of these countries, they're pumping out whatever they want. They don't care. Whatever it takes, the cheapest way possible to provide all of these things to the people that are reducing emissions, that are trying to reduce emissions. It's a fascinating thing that's happening. That aside, let's say once all of this is done, all the engineering is done, all of the software, and like I said, this isn't everything. There's still all the wiring that's associated with this, all of the software and processing that goes into these things in order to utilize all of this and interface it with how the truck runs. So all of that. So, and then once it's on the vehicle is less efficient. It gets less fuel economy. In some cases, on these diesels, 50% less, which means you're using more fuel, which requires more transportation of said fuel to be at the pump. So where does it, I mean, it's, when you put it all in front of you and you kind of start thinking about this, does it make sense? Does it work? I mean, that's my question. Is it working? Now, there's always the controversy concerning emissions and things like that. And this is in no way, shape, or form a means of advocating higher emissions or things like that. You have to think, if you look at it all at one time, you have to think, there's got to be a better way. Does it really take all of this to have better emissions? I think there's a lot more that can be done in tuning. All of the hours and hours of engineering. Stop loading down the engines with peripherals. Just make a better engine. Well, that concludes today's application of logic to an illogical situation. Thank you so much for watching. Please like, share, and subscribe, and we'll catch you next time.